You are welcome to Solo for Math. In this episode, we are going to cover solutions to the previous end of term exam that I shared, Senior 5 Mathematics. And in this part, we shall be covering solution to item 1. Those who checked, I shared this question. Item 1 says a weather monitoring station system uses a rotating sensor arm that moves in a circular path, and the signal strength received from the sensor varies depending on its angle of rotation theta. The signal strength at any angle theta is modeled by these two functions. So to ensure reliable communication, engineers need to know the strongest and weakest signal levels the system could possibly reach during its rotation. Task A, we are required to determine the maximum and minimum possible signal strength received by the system in each case. And then part B, as we shall see. So finding the maximum and the minimum, we are going to use these two functions here given. So we are going to handle a case at a time. So starting with the first case, where our function is f theta equals to 5 cos theta plus 3 sine theta. This function here can be related to the R formula, which is R. We can choose either cos or sine. Let me use sine. R sine, it means since we have a positive here, this will be theta plus an angle alpha, where R is the square root of 5 squared plus a 3 squared, which is equal to a square root of 34. Now, why do we relate to the R formula? Someone else would say, why don't we just substitute cos theta as 1? Because at maximum, our cos is always equal to 1, and our sine is also equal to 1. So why don't we just substitute 1 and 1 here? The reason is the two functions here, these ratios here, cannot all be at maximum 1 at the same time. So that's why we need to relate them into one function, one trigonometric ratio. Then we substitute for the 1 as a maximum, because both of these cannot be equal to a 1. They cannot all be equal to 1 at maximum. The same case for the minimum, they cannot all be negative 1 at the same point at the same time. So we need to relate them to 1 ratio, and then we go on with substitution. So it means our function has become a square root of 34 sine theta plus alpha. Now at maximum, if you want to find the maximum signal strength, our sine is equal to, we know it is equal to 1. So wherever we have sine and all of this angle, we shall substitute a 1. So this will be a root 34 times a 1. So it means our maximum strength is a square root of 34, which is approximately equal to a 5.831. Now, what about the minimum? Our function theta was related to a square root of 34. We have a sine theta plus an angle of alpha. Now at minimum, we know our sine of any angle, in this case sine theta plus alpha, is equal to -1. So it means our minimum signal strength expected is equal to square root of 34 times a -1, which is equal to negative root 34, which is approximately equal to a negative 5.831. Now, someone else will go on, we can go on and also find the angles at which the minimum and the maximum are given, but according to the question, it was only required to find the maximum and the minimum. So let me go to, if we go to part 2, where our function of theta, was 1 over 3 plus sine theta minus 2 cos theta. So since this is a quotient, I will begin by maybe letting my theta be equal to the denominator here, so that I first manage the denominator and then come back to the final question. So I can choose to first find the maximum of this function and the minimum, then that will help us find the maximum and minimum of this quotient. So if you want the maximum and minimum, we still have to relate this to one trigonometric ratio. So this will be the same as 3 plus. Now this could have been cos r cos. Since we have a minus here, so probably this was cos theta plus alpha, where our r equals to a square root of 1 squared plus negative 2 squared, and this is equal to square root of 5. So it means our g theta can be rewritten as 3 plus root of 5 cos theta plus alpha. Okay, now can we find the maximum of this? If we want g maximum, we know at maximum our cos is a 1, so we substitute this as a root 5 times a 1, which gives us a 3 plus a root 5. Then the minimum, which is equal to 3 plus root of 5 times, because at minimum the cosine is always negative 1. So we have 3 plus negative root 5, which we can write as 3 minus square root of 5. So this is a maximum and this is a minimum of this function. Now, when is this function a maximum? When is it a minimum? If you want to maximize this function, then we always minimize the denominator. Okay? If you want to minimize this function, then the denominator has to be maximized. So to find the maximum strength, we are going to use the minimum value here of the denominator, which we related with g. So if we go on, therefore our f theta max will be equal to 1 over g theta minimum. We said if we want the maximum, then the denominator should be minimum. So what was this? This was 1 over 3 minus root 5. And then our minimum is equal to 1 over g theta max. And this was 1 over 3 plus root 5. So that is the maximum and minimum of the function, the second function. If we go back to our question, determine the maximum and minimum possible signal strength received by the system in each case. We've finalized with that. We've gotten the values for that. Now part B, comment on your results and give the importance of minimum and maximum values in these functions in real life. Now, if you look at these results, for the first case, we had the signal strength ranging between negative 5.831 and a positive 5.831. Now this clearly shows that at some point the signal for the first function, the signal is lost because in between here we have a 0. So the signal goes to a negative strength, a very low strength. So this means that the engineers have to find a way in the design as they design the equipment that will use this signal. They should make sure that the equipment will receive or will be so sensitive to be able to accommodate or to be able to receive the minimum strength. For example, no one would want to buy an antenna that will lose signal at some point. So after knowing the minimum and the maximum, therefore we should design something that should be able to be maybe so sensitive, should be calibrated so that even at the minimum strength, at least the device can be able to get some signal or something. Then if you look at the second, we can see that the values range between in the highest is this 1/3, 1/3 plus root 5. Okay, this is 0.19, maybe 1, and then this is 1.309. Now, commenting on this shows that the signal is always positive. So we don't expect at any point to lose signal. Yeah, this is what we can comment from here. That the signal, because this is positive. It always varies, but it will never go to 0. So we shall always have a signal, though it varies in strength. Like this is a lower strength, this is a higher strength. So even here in the designing, a lot can be put in consideration that even at this minimum value, the devices that are to use this signal should be able to sense this so that we don't lose signal. Now, the applicability of the maximum and minimum values of these in real life, as we can see, one of the most important roles or importances of the minimum and the maximum values, they can help us in designing, as we're designing the components or the equipments that are used together with these signals. For example, where we see that the minimum value will always be less, a negative. So it can guide the designers of the equipments so that even at the minimum values, we can be able to receive a signal. That is one. Two, it can help us to avoid maybe wastage of electricity. For example, maybe in the control systems, when the signal is expected to be high at a certain point, we may not need to have amplification of signal. But if you don't know what to expect at a certain point, it means that you may amplify when it is not necessary. So that we only amplify when it is necessary. For example, at low signals, like these signals here, we amplify, but at a certain point we expect high signals, so we don't need to amplify. Yeah, I think that is it. Thank you for watching. Consider subscribing if you found this useful, and share and comment where there is any need to. Goodbye.